the electric field at a point is. Out of the given options, you have to choose which are the correct options. So pause the video and read all the options carefully. Okay. Now consider a point charge. Say this is a positive charge. Now we know that field lines will emerge out of this positive charge. Now as these field lines are emerging out of the positive charge, now where they are moving, so we assume them to be moving towards infinity, and further assuming that negative charge is placed at infinity, because from the property of field lines we know that the field line starts from positive charge and end at negative charge. Now here he is talking about the term continuity and discontinuity of the electric field intensity at a point. Now what do we mean by continuity and discontinuity? Continuity literally means that anything that is continuous, means for a given point there is a value that exists before that point and there is some value that exists after that point. Means that if we consider this point P, so if the field lines are continuous, means they are moving further through this point P, means the field lines cannot sink at this point P. Clear? So by this we mean that the field lines will keep on moving further, means there exists some value before this point for the field and there also exists some value after this point. Clear? Means field lines cannot sink here, means there cannot be any abrupt change in the field at a particular point. Clear? Let's understand this situation with an example. Now consider this point and assume a Gaussian surface. So this is a Gaussian surface. Now if you look at this Gaussian surface, this flux line is entering this Gaussian surface and hence the flux associated with this Gaussian surface is negative. Clear? Now from the Gauss law we know that if the flux associated with the closed surface is negative, this means definitely there is some negative charge inside the Gaussian surface. Only then the flux associated with the Gaussian surface can be negative. But here we know that there is no charge inside the Gaussian surface. Clear? So the net flux that will be associated with this Gaussian surface must be 0. Now for that the field line must have to pass through the Gaussian surface, means the field line must flow out of the Gaussian surface. Clear? This means the field line is continuous. Now in order to understand the discontinuity of the field means that there is an abrupt change in the field, value of the field. Then we can say that the field is discontinuous at a point. Now how this discontinuity appear? Say we have a negative charge here and the field line starts from this charge and terminate at this negative charge. Now if I consider a Gaussian surface around this charge and this Gaussian surface is very small, so the field value just near the charge is very high, means the value of the field as soon as we approach the negative charge, the value of field will increase tremendously, means there is a very large change in the magnetic field and the field lines are sinking here. Or you can understand this discontinuity in another way. Let us consider this metal plate, and due to the presence of this positive charge, here we have a induced charge. So this is negative on this side, positive on this side. Now if a field line that travel from this positive charge, so it will touch this metal surface perpendicularly. Clear? And this will emerge out from this side. Now in between this situation, in between this space here, the value of field is 0. So we have a value of field on this side of the surface, but abruptly the field becomes 0, and from this 0 it again the field will again appear on this side. So here we have a breakage in the line, means we have a discontinuity in the field. So this discontinuity can happen only if there is a charge entity in between. So here we have taken positive charge, so correspondingly there is a negative charge situation. So if we had taken negative charge, so corresponding there will be some positive charge entity. Clear? So, and you can understand this continuity and discontinuity. So let's take some example. Say length of your hair. Length of your hairs is a function of time. Clear? So with every instant of time, the value of the length of the hairs is increasing. Clear? So it will assume, the length of the hairs will assume all the intermediate values between two given lengths. Clear? So it is a continuous function of time. And if we consider the balance amount, money in bank account, as a function of time, now this function is discontinuous. Whenever you withdraw or deposit the amount in your account, there is an abrupt change in the value of the money deposited in your bank account. So the money in your bank account as a function of time is discontinuous because there is an abrupt change in the value of the money deposited. So mathematically at your level you can understand this difference between continuous and discontinuous function. We can take another example also. Say this is a pipe. Clear? And from Bernoulli's theorem you know that AV is equal to constant. So that was the continuity equation there. So from the what continuity equation says that this A into V, that is volume per second, the volume of liquid that is passing per second through any part of the pipe is always constant. Say a given amount of volume that is passing through this region of this pipe, and if we consider another region of this pipe, so the volume per second that will flow here in this region and in this region is always same, and this volume per second is also constant in the intermediate space between these two locations, and this volume per second is also continuous here between these two states. Means this is continuous, the flow is continuous, means from here to here the liquid is present at every state. This doesn't mean that here is the liquid flowing per second and here the liquid disappears suddenly and here it appears again. Means there is a continuous flow of the fluid. So that's why it was called the continuity equation. So just like the flow of fluid here, so we have a flow of field lines here everywhere around a charge distribution. So if there is no charge present in a situation or in a state or in a space, so the field lines will always be continuous, and they are discontinuous only if there is some charge present. So using all this information, so we can say that the electric field at a point is continuous if there is no charge at that point. This is the situation, and it is discontinuous if there is a charge at that point. So options B and D are the correct options.